Hello, welcome back everyone. Today we will be entering chapter 7, which is on gravitation. So there's three subtopics in this chapter. So the first one is on gravitational force and field strength. So in this subtopic, you should be able to state and use the Newton's law of gravitation, which is this one. And then lastly, you should be able to define and use gravitational field strength. Okay, so what is actually Newton's law of gravitation? Well, it states that a magnitude of an attractive force between 2-point masses, for example, these 2-point masses is directly proportional to the product of their masses. Okay, so Fg is directly proportional to the product of the two masses, and then inversely proportional to the square of distance between them. So it is it is inversely proportional to the square of distance between them. Okay, so this is mathematically, or you can also write it down as this formula itself lah. Okay, all right, so G here is the universal gravitational constant lah. Okay, it is the universal gravitational constant with the value of 6.67 times 10 to the power of negative 11. Alright, so graphically pun boleh lukis. So you can draw two masses lah. Contohnya, this is the moon and this is the earth. So this gravitational force can be written as F21. Okay, so what does 2 and 1 means? 2 is the gravitational force by mass 2 on mass number 1. Okay, alright, what else? So this is the variation of gravitational force with distance. So we know that the gravitational force is indirectly proportional to the square of distance between them. So if you write 1 over r square, it will show a graph that is directly proportional to 1 over r square. Okay, so this one untuk inversely proportional lah. Okay, alright, so every spherical object, you should note that every spherical object that has constant density can be reduced to a point mass at the center of the sphere. Lepas tu the gravitational force are always attractive in nature, and it acts along the line joining the 2-point forces. So contohnya di sini ada line yang join them. The forces will the forces always act along this line lah. Okay, untuk yang ini pula, even though that it is a spherical object, it can always be considered as a point mass. So we are just gonna look at it at the center of the sphere lah. Sekarang akan tengok di center sahaja. Alright, okay, let me see if there's theory. Okay, there's this. Okay, so the next theory is on gravitational field strength. Okay, so what is gravitational field strength? It is a region in which a body experiences gravitational force. Okay, so the body is experiencing a gravitational force. Okay, if a test mass is placed in the region lah. Okay, so this arrow here yang I've drawn, the arrows are actually telling us the direction of the field. Okay, so the arrows are the direction of the field. Lepas tu the spacing pula, this space here sama pula color dia. So this space between these arrows are known as the strength. Okay, this is the strength of the field. Okay, boleh ya? So the gravitational field in smaller region, for example near the Earth's surface, are actually uniform and can be drawn parallel to each other, as can be seen here lah. Okay, so that is on gravitational field. Let me check if I've missed out on anything. yeah, so for radial object, obviously you will draw the arrows in this way lah. So it is moving in onto the object radially lah. Okay. Okay, that's basically the important bits. Now we are going to look at gravitational field strength. So gravitational field strength is also known as gravitational acceleration. Okay, so if dia tanya gravitational field strength, it means that it wants to know about the acceleration lah. Okay, so it is defined as the gravitational force per unit mass of a body. Alright, mathematically you can find it by using this formula. Okay, it is a vector quantity, so it does have direction, and it has the unit Newton per kilogram or meter per second square lah, meter per second square lah. Okay, also known as gravitational acceleration ataupun free fall acceleration. It has the same direction with the gravitational force, and then you can also calculate it by using this formula here. Okay. Okay, I've defined each variable. So that is for the formulas on gravitational field strength. Alright, now you have to focus on the variation of gravitational field strength on the distance from the center of the Earth. Okay, so now let's look at this. So for outside the Earth, in which the distance between the task mass and point mass ni are greater than the radius of the Earth. Okay, so if this is the case, you will continue using this formula here, which is this one. If it is on the Earth, where r is equal to the radius of the Earth, we will then get the gravitational acceleration to be equal to 9.81. Okay, so this is the acceleration kalau dia punya distance between the two masses is equal to the radius of the Earth. Okay, lepas tu, if it's inside the Earth, you will be using this formula here. Okay, so r besar ni maksud dia it is the radius of Earth lah. Okay, and then this is a graph showing the variation of gravitational acceleration strength as a function of distance from the center of the Earth lah. Okay, so make sure you can draw this well, because sometimes they will ask you to draw a graph. You have to plot a graph lah. I mean, sketch a graph, something like this lah. Okay, so basically this graph is saying if the distance is equal to the radius of the Earth, the gravitational acceleration would be equal to g, which is 9.81 meter per second square. Okay, if it's outside the Earth, it will the gravitational acceleration is inversely proportional to the square of distance lah. Okay, right, so I think that's the end of the theory part for subtopic 7.1.